Hello everyone, I'm Tamás Rovas from BME, and this is the Capture Reality module, and today and this time we will talk about mobile mapping. So mobile mapping, when you are putting the sensor on a mobile platform, either you carry it or you put it in a car, on a vehicle. So we are talking about mobile mapping systems. I will show you some use cases. I will show you some different sensors, for example, ground penetrating radar. I will show you wearable systems and some examples to indoor survey. So mobile laser scanning, it often combines different sensors. That's what we call sensor fusion. And at the end, we need to use data. We need to apply data fusion. So in such mobile laser scanning systems, there are simpler ones and there are more sophisticated ones. For example, in Hungary, the Hungarian Road Authority is using one complex mobile scanner that has two laser scanners on it and multiple cameras, and that enables to create the high resolution and color point cloud of the road and road environment. So the concept, what are the system components? We need to have a platform. It can be any kind of vehicle, a car, a ship, or whatever. We have a positioning unit that is giving both location data and orientation data. So where you are and where you look at. So that's the two data you need. And obviously there are different sensors on them. We call the positioning sensors also sensors, but there are, in most cases, there are cameras collecting images and laser scanners collecting point clouds. And we use the camera images for coloring the point clouds. Okay, in the road authority use case, at the end, they need to derive abstract data about basic data from the road surface, where the road markings are, where the edge are, where is the road shoulder, where are elements, road furniture, signs, whatever. They want to segment and then classify from the point cloud, and they are using it for the maintenance. About the systems, I will show you, there are multiple examples, so I will show you only some. That's, for example, the Leica Pegasus mobile mapping system that, again, have Novatel GNSS and IMU, so that's the location and positioning navigation unit. A ZF LiDAR system for the laser scanner. It has a 200 rotation capacity per second. The maximum range is 120 meters, so it's quite enough to survey the road, the nearest road environment, and it has 7 RGB cameras mounted on the platform. There are simpler systems that are also enabling SLAM technology, that's the simultaneous localization and mapping, when you don't have a pre-designed trajectory, but you are continuously mapping the environment and navigating yourself in it. But these systems can be also available with GNSS methods. You can fuse the data with other interesting sensors like ground penetrating radar when you want to check what kind of utility systems, pipes are underground, and what's their diameter and depth of build, and you can use mobile mapping systems combined with ground penetrating radar and the current systems providing high accuracy. And again, I want you to pay attention to the technical specifications that provides information about the range, the ranging accuracy, and surveying environmental requirements. Okay. The human-powered mobile mapping systems, either we are carrying in a backpack, or we are wearing the sensor, or we are pushing or pulling a trolley or a trolley, and all the sensors are there. These are much more expensive equipment than compared to terrestrial laser scanning. So we are in the 100 to 200,000 euro range, and these systems applying laser scanners and cameras. And but there are main difference. For example, if you are considering a trolley or a pulley, you need a flat ground. But if you are carrying a backpack, you can go on rural areas, you unpaved roads, you can walk on stairs. So there are different applications enabled with this technology. And obviously, if the platform is always moving, you need to compensate it, you need to calibrate it, you need to always compute from the navigation data actual position and orientation of the sensor. So that's why it makes it tricky. In case of indoor survey, there are multiple solutions. I show you the orthograph solution. They use a tablet or a phone screen to draw with easy distance measurements. You can map the floor plan and the 3D model of the building, and if it's connected with a BIM database, it can be used for operational BIM applications. So if you want to evaluate the mobile mapping technology, is the main advantage: efficient and fast data capture. Imagine that you don't need to just put the scanner on a tripod and then wait for 2 or 4 minutes for scanning, but you are walking in a walking speed, or you're putting in a car and walking at 40 km/h, and you are capturing the data. It provides color and 3D data simultaneously. The disadvantage is the big data. So it's a performance challenge. You need to resample it, you need computing capacity, and obviously very expensive instrumentation required. And obviously, on the other hand, you cannot compare the quality of the data set to that of the high quality terrestrial laser scanning, so don't expect 1 millimeter accuracy surface models from mobile scanning, but we are still in the millimeter range. So that was about mobile mapping. I collected the references, the sources I use, so feel free to look them up, and thank you for your attention. In the next video, we'll talk about scan to BIM technologies. Thank you and goodbye.